All right, welcome back for problems starting at 7, right? So we're starting at 7. Getting right into it, it says fill in the blank with a number to make the expression a perfect square. And if we forgot, well, what does this mean to be a perfect square? We'll talk about that again in a second. And so we'll do two examples of this. My first one here is x squared plus 2x plus something, right? So we want to know what that plus something is. Let's go ahead and jump over to, looks like I closed out one note. We're going to need that back. We'll add another page. And we'll get going, right? So I'll do two examples of this. And I'll show you my algorithm that I like to use. So we have plus 2w plus something. And so the whole goal of this, right, a perfect square, is we want to have this in the form of w plus or minus, I don't know the sign yet, I'll just leave it, something squared, right? So this is what it means to be in this perfect square format. Now, the algorithm we want to use here is we're going to look at this middle number, in our case 2, and we're going to divide it by 2. So always, right, always divide by 2. Right, we divided by 2, we got 1. Our next step is then to square the new number, square number. So now if I square it, in this case it's a very nice case, right? I still get 1, right? I have 1. Right, so the number that we want here is just a plus 1. And the good news is, and this is in every case, we're going to do another example because this one's kind of a one-off. This number here is what we're putting in our perfect square format. So we end up with w plus 1 squared. W plus 1 squared. And you can always go verify, right? So we can take this, we could factor it all out. We should end up with w squared plus 2w plus 1. Right, I want to do a different example because this one wasn't, you ended up with the nice value of 1 there, right? All right, so it's just a 1. Let's try one more. And it doesn't look like it wants us to put it into perfect square format. It's just looking for that actual value. That's the same one, isn't it? Here we go. U squared minus 18u. All right, so let's do, we have a u squared minus 18u plus something. So again, we look at the middle number. It is a negative 18. I'm going to always divide by 2. I will get negative 9. Now in this case, right, I take that negative 9. So I'll write down here, negative 9, and I'm going to square it to get positive 81. And so that is the value I'm looking at, right? Now, again, it doesn't ask for this perfect square format, but in this case, it would be u minus 9, right? Notice that it's this number right here, u minus 9 squared. And again, you could take this, factor or distribute it all out. You'd end up with u squared minus 18u plus 81. So again, the algorithm is divide by 2 and then square, right? Divide by 2, then square that middle number. Okay, right, completing the square, normally one of the trickier problems for this exam. Let's go ahead, 81. And we'll do another one here. Let's go on to our next problem, number 8. Solving, let's see, what is this called? It says solving a rational equation that simplifies to linear. Okay, so we're just solving for v here, right? And this is negative 2v is equal to 6. Negative 2 divided by v is equal to 6. And we want to solve for v, right? So right now v here is in the denominator, or right, it's in the lower part of that fraction. I need to move it up first, right? So I'm gonna, if I have this and I want to get v to the other side, right, I need to multiply both sides by v. So on the left side, my v's cancel out, and now I do have v, right, hanging out kind of in the upper part of a fraction, or in this case the numerator. but I do want v to be by itself, right? So I need to divide my right side by 6, but if I do that to my right side, I must also do it to my left side. All right, so we end up with v is equal to negative 2/6, but the last thing you need to do is make sure that you have as simplified fraction as possible. In this case, right, those are both even numbers. They're going to be both divisible by 2. And so this is the same as negative 1/3. And you can always go verify, right? You can always go verify your answer, plug it back in to the starting point, and make sure that's a true statement. Let's go check. Negative 1/3. So that was number 8. So moving forward, number 9, right? If we forgot the equation for a circle, don't worry, I will remind us here. Actually, I don't need to remind you because it is already, or I guess I will, I'll write it down on paper here. I'll go through this one and then I'll remind us of the equation, right? So you could think of, for the equation of a circle, it's kind of the opposite sign that you would think. So in this case, we have a +3, it'll be a -3. We have a +2 for our y value, it's going to be a -2. And our radius here is the square root of this number 25. And so if that looked familiar and you understood all that, great. Oh, I'm supposed to graph as well. If you understood all that, great. If not, I'm going to remind us of the equation here shortly. Right, now, once we have this information, let's just make sure we graph it right. I like to put a point, and I go put the point at exactly what I just said, -3, -2, just so I have it on my graph. I don't think it marks it wrong if you don't do it. And now, my circle, I place it at the middle, and my radius needs to be 5, right? So there's a couple ways to do this. I look at the x value. My x value right now at my center is -3. And so if I just move my x value to, right, this would be 0, I've moved 3 units, 4 units, 5 units. Oh wait, I need my center. Let's place my center. There we go. And so I'm just going to move my radius so that I have a radius of 5. Perfect. Okay, now if you forgot the equation of a circle, that's okay. Right, I will remind us. The equation of a circle, and then I'll use our example we just did, is x minus h squared plus y minus k squared is equal to r squared. And so notice these are minus signs, right? X minus h, y minus k. Our example we just had a plus sign, right? So that's why I just say it's kind of the opposite sign that you would think. This was our example here. I'm going to rewrite it one more time so it's a little bit more obvious. X minus -3 squared, so there's where my -3 is coming from. Y minus -2 squared is equal to 5 squared. And again, I'm writing it as a y minus and an x minus just so it's in the same format as our equation. And so now it's pretty clear that our hk, which is our center, is -3, -2. And again, our radius, this is r squared, our radius would just be 5. And again, I know I'm going quickly. I keep saying this, but feel free to rewind, rewatch, send me messages, ask questions. Totally fine. That was number 9. And so we just had the equation of a circle, so let's see if we can reference it again here. Okay, so in this case, this is like a combination of the circle question, which is what we just went over, and also completing the square, right? So we want to kind of get this into a circle, the circle equation we just looked at, so we can enter the center and the radius. And so we have x squared minus 6y plus y squared minus 7. X squared, let's see if I can remember that. We have x squared minus 6y plus y squared minus 7 is equal to 0. And my goal here is to get it to look like this, right? Our equation of our circle. And so the formatting, or the way that I like to go about this is, well, let's get all of our x's and y's on one side. right? Right now, this minus 7 here isn't really helping us. Let's go ahead and move it. And I'm going to rewrite this. So we have y squared minus 6y is equal to 7. My next step is I'm going to group my x's with my x's and my y's with my y's. Now, this is a nice one, right? So I have x squared, and there's nothing else to group here, right? It's all by itself, but I'll group my y's together. I'm just going to put a plus something here, right? Same way we did the completing the square. Now, the good news here is the x's are actually already done, right? You could think of this as an x minus 0 squared. You don't need to write it this way, but I'm going to leave it just so you can see this already is in the kind of the circle format. Now for the y's, we're going to go about completing the square the way that we did before, right? Meaning I'm going to look at this middle value, right? My middle value is negative 6. I'm going to divide it by 2. I get negative 3, right? We divide by 2, we get a value, and we square it. Right now, some of you may have noticed, you're like, wait, from our original equation, we can't just throw a 9 in there, right? We just added 9 out of nowhere. Well, you are correct, right? But if we add 9 to the left side of this equality, I have to go add 9 to the right side. And so now once we've added 9 to both sides, I have x squared plus, this now turns into, let's put this into perfect square format so I can see the center of my circle. Right, this turns into y minus 3 squared plus 16. Equals 16, I'm sorry. Equals 16, not plus 16. Equals 16. Now again, please take your time. I'm going through this process quickly, but take your time going through this process. Right, I'll probably do one more. Right, we took that middle number, we divided by 2, we squared it, and then we're putting it into perfect square format. And so in this case, this tells me my center, because I don't have an h here, right? This is x minus 0. I know my x value is 0, and my y value here is going to be a positive 3, right? So here is my center. And again, this is my radius squared. Be careful. Very easy mistake is to think this is your radius. This is your radius squared. So our radius here is going to be 4. And I'm going to do another one, right? So go back, watch that one if you would like. I'm going to find a trickier one where we have to change both the x and the y values. So 0, 3, and 4. I'm just going to try another. Okay, so here's a good one. No, we want a different one. Here we go, right? So here's a bunch of x's, bunch of y's. Let's go ahead and try this one all together. We have x squared plus y squared plus 8x plus 6y plus 9. Let's see if I can remember that. There's all plus signs, that's the good news. 8 or x squared plus y squared plus 8x plus 6y plus 9 is equal to 0. So I'm going to do the first two steps at once. I need to group the x's with the x's, the y's with the y's, and I'm going to move anything that isn't an x or y to the other side of the equal sign. And I'm going to leave a blank here. Same way I did in the previous problem. Now if I move the positive 9 to the other side, I get a negative 9. So be careful there. And so now think about we're doing completing the squares, but we're doing it twice. Right, so let's look at this one first. Right, I have an 8. I divide by 2. I get positive 4. And I square it. I take my middle number over here. It's a 6. I divide it by 2. I get a positive 3. And I square it. And then remember, right, we don't just get to start adding stuff for free. I've added a 16 and I added a 9. So if I add 16 and I add a 9 to the left side, I also need to go over here to the right side and add a 16 and add a 9. I'm going to highlight these, right? This is what's going to help us put it into perfect square format, these values when we divide it by 2. And so now I have x, we have plus 4 squared plus y plus 3, so notice those two highlighted numbers there, squared, is equal to, well, I have a plus 9 and a minus 9. Those are going away, equals 16. And so in this case, right, our center is the opposite sign that is kind of listed here, right, because it's x minus h, so this would be x minus a negative 4. So we have negative 4. And y minus a negative 3. So we have a negative 3. Here's our center. And our radius, again, this is r squared. So if r squared is equal to 16, this means that r is equal to 4. So feel free, again, pause the video because I'm going to close out and we're going to keep moving here. But obviously, totally fine to keep staring at that problem, one of the more complicated ones here. I think this is the one we just did, right? Yeah, we just did that one. That was number 10. Now we get into some nice problems, right? Those were the first circle ones are a little bit more. Now, remember I said we just need a definition of relation versus a function, right? A function means one input gets one output, right? That is we'll say our definition. If we have more than one output, right? Meaning, let's say I plug in a value A and I get out two outputs. That is just a relation. And so let's go through each one, right? T goes to X, X goes to E, J goes to H, S goes to X. Now, the quick way to check these are to look at your domain, which are your inputs, and see that each one of these letters is only listed once, which is good. If it's listed more than once, that would mean it has two different outputs, or in other words, it has two different values in our range. So if it's listed once, 1t, 1x, 1j, 1s, only listed once, we have a function. We're going to contrast that with relation number 2 over here. Right, relation 2, you'll notice that 4 here somehow gets mapped over to paper, but 4 is also getting mapped to desk. This is showing that one input in our domain has two different outputs, paper and desk, in our range, and because of this, it is not a function. So this is showing it in this nice table format. You can also see it in this nice paired wide format sets, right? And again, I'm checking the domain. Let's just check the domain, right? Which are x values, -2, +8, -1, -4, right? The x values here in our points. They're only listed once. That's good. That means every input is only going to have one output. You'll notice here in our relation 4, right? I have my inputs of F, E, F, and F, right? So F there is 3 times, and notice that F is getting mapped to -7, F is getting mapped to +1, F is getting mapped to -6. It has 3 different outputs. That's not good at all, right? So not a function. And let's do one more, right? So that's a way to identify a function there. And we also want the vertical line test. This is another way of identifying relations versus functions if you're given a graph, right? You want to think of the vertical line test as, again, telling us that one input gets one output. So in graph 1, if I drew a vertical line anywhere here, I would hit 2 points. I'm going to give you... Okay, I'll have to chop that out so you don't see an Excel file of my bills. Just so you guys can see a graph here, right? So let's pretend we'll do a nice circle, right? This would actually be not a function, and I'm going to write this, right? So the test that we're going to be doing here in a second, known as the vertical line test, shows that if I draw a vertical line anywhere on my graph, I'm only allowed to hit 1 point. If I hit 1 point, then I have a function. If I hit more than 1 point, which on this circle, right, I hit a point here, and I hit a point here, then I am not a function, right? So I only want to hit 1 point. Let's go back. And now we can see, right, graph 1, I'm going to hit multiple points, so not a function. Graph 2, I have 3 points all at x equals 4. So notice that 4 maps to 0, 4 maps to 3, and 4 maps to -2, right? So if I drew a vertical line, I'm going to hit 3 points, so no. Graph number 3, right? If I draw a vertical line, for instance, at x is -6, I'm going to hit multiple points, so no. Lines are nice, yes. Notice at graph 5, if I drew a line at x equals 0, I'm hitting multiple points, so also no. And let's see, graph 6, only 1 point at -5 for x, 1 point at -3 for x, 1 at -2, 1 at +3, and 1 at +4. So this one's also good, right? If I draw vertical lines anywhere, I'm not going to hit 2 points for graph 6. Okay, so this one went a little bit longer than I wanted. Hopefully you guys got through that. Again, please rewatch, ask questions, slow down the video, or jump to just the problems that you need, but I will see you shortly in video 3.